So far we've been doing things that are nice and easy. Don't go there. What is the square root of x to the 14th? You say it like it's so easy, right?
I got that wrong.
What's the square root of x to the 15th?
Oh, I feel you.
Please don't. I don't. That makes me very uncomfortable. Now, we're not going to say 7.5. Now, you're on the right track that, 14 divided by 2 is 7.
But
I want to make sure that it's nice and neat. Because what we're really looking at here is I can break this down to be x to the 14th times x to the 1st. Do you all agree? And the reason I'm doing that is because I can see here that this guy is my perfect square because I know the index goes into that exponent evenly. And what do you get? X to the 7th with how many left?
With the single one in here.
Now, since we were doing division before to make this nice and easy, what's 15 divided by 2? Well, 2 goes into 15 7 whole times with a remainder of 1. Right? So if we look at it that way, is the quotient and then the remainder, then it's nice and easy. So what do you think would happen if I wrote this? If I said the 5th root of x to the 17th? Does 5 go into 17 evenly?
That would be 9.
5 goes in here
3 times.
3 times with the remainder of what? So you'd have 2 factors of x left over. Do you all agree?
Something like that. That's awesome.
You all agree?
I do.
Okay. What about your index?
It's going to be to the. Oh,
It's still the 5th root, right?
Yeah.
So don't drop that.
I told you, you're skipping steps. So you're supposed to do it.
See, here's what I'm saying. Now, this is what I had said.
See what had happened was.
Yeah, see what had happened was, I rewrote this guy in my head as x to the 15th times x squared. Now, why would I do that?
Because you're adding exponents.
Well, if I multiply, I would add exponents to get back here, but 5 goes into this guy evenly, right? 3 times. But it doesn't go into this guy at all. So that's why the leftover part is on the inside. So really I'm just asking you to do long division and keep track of things in your head. Or you can write it out because sometimes things get super crazy. If I have the 7th root of x to the 433rd power.
Quit.
No, you sound like an error message on the calculator. You have 2 options, you quit or go to. A lot of times you guys quit, and that's a horrible life choice. Go to. Go to the problem, identify it, fix it. Okay? So what I'm going to do here is I know that I'm trying to do 7 into the exponent of 433. What?
I was going to divide by 6.
Yeah, 6.
Why would you divide by 6?
Seven
That's
No,
7.
6 at the top. 6 times 7 is 42.
Oh, I'm sorry. I did not know where you were on that.
7 goes into 13 once.
So we get a remainder of 6, right? So that means my answer is how many complete sets of 7x's do I have in there?
We have a complete set of 61.
I have 61 sets of 7x's because this is what it's saying. The 7th root means I need to have 7 of the same factor. So if I wrote out all 433 factors of x, how many sets of 7 would there be? There'd be 61, but what would happen to the end?
There'd be 6 left over.
You have 6 left over. That's why I still have
6 on each side with 7 on the outside.
the 7th root of x to the 6th. You guys with me on that? So let's try this one. How about the square root of x to the 21st, y to the 12th, and z to the 35th? Let's piece by piece look at this. If I just have this guy right here, what are you going to get from that? You get x to the 10th, but you're going to have some x left over, right? Now, before you start writing anything about that, know that you're going to have y and z factors to pull out, right? So leave some space for the y and the z factors. Now, how many factors of x do I have left?
One.
I have one factor of x. Move on to your y's. The square root of y to the 12th is going to give me what? I get y to the 6th. How many factors of y would be left over? None, because it goes in there evenly. So do I need to put anything back in the square root? No. Do that again into z to the 35th. What do you get?
17.
I get 17 with what left over? With one z left over. All I'm asking you to do here is really, divide. That's all you have to do. What do you guys think about that one? Perfect. All right, I think you're up for a little bit of a challenge. I don't want to hear you guys disagree with me. How about the square root of 162, x to the 52nd, y to the 25th?
I would say 162.
What am I going to do here?
So it's 12.
So what's the square root of 162? It's 81? How'd you get that?
Oh, no.
Now, there's a difference between this guy and those guys. There's a difference between a coefficient and the exponents. Is 162 a perfect square?
No.
So we need to-
Get to is 12.
I don't want to get close to it. I want to be able to factor it. I need to break it down using multiplication, not addition. That's why we talked about those bad things earlier. How can 162 break down?
81 and 2.
Now, when I say 81 times 2, I don't need to go any further than this. Why not?
Because 81's a perfect square.
81 is a perfect square, so as soon as you recognize you have a perfect square, you're done. You don't need to do anything else with that. Okay? What's the square root of 81? 9, and I'm going to have what left on the inside? Now, notice I left some space there between the 9 and the square root. Why is that? I have variable factors I still need to bring out. How much x gets to come out?
26.
I get x to the 26th. How many x's are left over? None. Okay, then what about your y's? The understood index of 2 goes into 25 12 times with what left over? With one factor of y left over. What do you guys think about that one? Any questions?